This is lesson number 4, distance and length. The essential question is, how do you find the distance and midpoint on a line segment? So the ruler postulate says that the points on a line can be matched 1-to-1 with real numbers. The real number that corresponds to a point is the coordinate of the point. So over here we have a line, and that line has 2 points, point A and point B. We're going to name A x sub 1 and B x sub 2. Remember that if a variable has subscripts, then those subscripts only talk about position. They don't say anything about value. So the distance between point A and point B is written as AB. So notice that this is just AB, nothing else with it. Is the absolute value of the difference of the coordinates of A and B. Now, what's important to note here is that, excuse me, this AB, it makes a difference. So, in the beginning, we learned AB that looks like this, and that was referencing a line. We also talked about AB with the bar, and we know that that is a line segment. But here now we have AB with nothing, and this is referring to the length of segment AB. So make sure you note that these are 3 different things. They look different, and they all 3 mean different things. So now it says find the length of segment BE. So we're looking for the length of segment BE. So because we're looking for the length of segment B, how do we write the length of segment BE? That's going to be written as BE. So then BE would have to be equal to, well, we got to figure it out. This point B would be x1. This point E would be x2. So then BE would be the absolute value of x2, which is 5, minus x1, which is -1. So 5 minus a -1 is 6. So that's going to be the absolute value of 6. So BE is equal to 6. Right here, I would strongly suggest that you pause for a moment and try to work the next example out on your own, and then come back and work it out with me. So I'm going to try to use different colors for each one. We'll start off with the length of MN. So this is going to be x1, this is going to be x2. So that means that MN is going to be equal to the absolute value of 4 minus 1, which is the absolute value of 3, which is 3. So here's now LN. L is x1, N would be x2. So I'm going to say that LN is equal to the absolute value of x2, which is 4, minus x1, which is -2. 4 minus a -2, 4 minus a -2 is 4 plus 2, which is the absolute value of 6. So 6, and if you wanted to check, you could actually count 1, 2, 3, 4, 5, 6. All right. So then KJ, here is K, so that's going to be x1. Here's J, so that's x2. So that is the absolute value of -5 minus a -3, which is -5 plus 3, which is the absolute value of -2. So KJ is 2. And then lastly, we have JL, and that is equal to, let's see, J, that's going to be our x1, and L, that's going to be our x2. So that's going to be the absolute value of -2 minus a -5. So that's -2 plus 5, which is a +3. So JL is equal to 3. And notice that on every single last one of them, I put nothing on the top, because these are all talking about lengths. So make sure you distinguish between that.